To get introduced to heights and distances, let's imagine that you are Superman, and in front of you there's a building, and on the top floor of that building, there's somebody who needs your help, an innocent citizen trapped by a cruel villain, a generic Superman story. And now if you're a normal man, then maybe you'll run all the way here, take an elevator and then go there, but you're Superman, so you decide to fly straight over there, and you want to know how far you have to go to reach there. In other words, you want to find the length of this line. And there are many ways you can find it, but because you're Superman, you come up with a way that you can do it really quickly. And one of the features that you have as Superman is that, I don't know if for the ones who are not familiar with Superman, Superman can shoot lasers from his eyes whenever he wants to. So now you can shoot lasers from your eyes. Now the thing about this laser is that it shoots exactly in the direction that you're pointing your eyes at that moment. So if you're seeing straight ahead without tilting your head up or down, then this laser points exactly along the horizontal. Now, okay, how can this be useful to find how far you should fly? And that's where things get clever. So what you do is that you start tilting your head up, 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 up until you reach the top of the building. Your laser reaches the top of the building and it's pointing exactly to where you want to go. And then what you do is that you find out how much you have to turn your head. That's all you did. You didn't have to go fly there. All you did was find out how much you had to turn this laser from the horizontal position till it points towards the top of the building. And you found that this angle is 45 degrees. Now that's a lucky coincidence because this could have been 63.275 degrees. But in this beautiful world, we got it to be 45. Now the question to you is, how will you use the length that you are from the building, the distance that you are from the building that Google Maps is telling him, and this angle that you had to tilt your head such that, how much should you have to tilt your head such that the laser points there? Using these two, how can you find the length of this line segment? Now notice here that the thing to notice here is that this building makes a right angle with the horizontal. That's the key idea over here, which means that you have a right angled triangle over here. Now that you can see a triangle, you can ask, okay, I know one angle. I want the adjacent. I actually want the hypotenuse. I know the adjacent. What ratio connects the adjacent and the hypotenuse? And you know that that ratio is called something. It's called cos. So if you have cos of 45, if you remember, or you can look up in a book the cos of 45, then you will be able to find this distance, which is what you want. So let's write D over here. And maybe you have a little book where you've written the cos of 45. The way I remember it is that I remember what I call the 45 triangle. I'm going to draw it over here, the 45 triangle. By that I just mean a right triangle that has a 45 in it. And I know that if this side of this is 1, this also has to be 1. That's what I actually remember, because this is 45 and this is a triangle, then this must be 45, which means it's an isosceles triangle. These two sides have to be equal. And then I can use Pythagoras theorem to just write root 2 over here, root of 1 square plus 1 square. And with this triangle in my mind, I can remember or look up all the ratios that I need. Sine 45 will be 1 by root 2, cos 45 will be 1 by root 2. In the case of 45, these two are equal, and tan will be 1. Cot will also be 1. So I can do that, and in this case, what I need is cos 45. So what I do is that I write, okay, cos of 45 degrees must be equal to the adjacent by the hypotenuse, no matter what size the triangle is. They're all gonna have the same ratios. That's why remembering these ratios are useful. So 100 by D. And now I can replace cos of 45 with 1 over root 2. 1 over root 2. And now, of course, you can just find the answer. If you cross multiply, you will get D over here and 100 root 2 over here. So D equals 100 root 2. And what's the unit? 100 root 2 meters. 100 root 2 meters. Now you can leave it here. I mean, that's what I'm tempted to do. But if you want to find what the answer is, root 2 is approximately 1.414. So 100 root 2 will be 141.4 meters. 141.4 meters. So there it is. You have it. Now, why did we talk about Superman and lasers shooting from the eyes? We did that because you don't have to be Superman to imagine a laser shooting from your eyes. If you're Superman, the laser will actually shoot. But if you're not, you can imagine a laser to be shooting from your eyes exactly in the direction at which you're pointing your eyes at that moment. And that line is what we call, there's a name for this line. That line is what we call the line of sight. Line of sight. So if you're not tilting your head above or below, your line of sight will be exactly along the horizontal. And then as you tilt your head above and above, your line of sight goes there. Your line of sight is basically that laser that shoots from your eyes in the direction that you're seeing. And then you keep tilting it, and maybe you reach another point. Now your line of sight is over here. Now, you had to tilt your head by 45 degrees from the horizontal, right? This angle is called the angle of elevation of this point as seen from you or seen by you. So I'm going to write this, the angle of elevation. Now notice why we have a name like this, right? I can now say, I gave you a big story. Superman shoots lasers from his eyes. He had to turn his head 45 degrees from the horizontal such that his laser points right at the top. Right? That was a long story. A much shorter way of saying this is that the top of the building has an angle of elevation of 45 degrees as seen from or as seen by Superman. That conveys the exact same thing. You will know, oh, okay, this means that the big version of that is this means that if Superman kept his, or anybody, doesn't matter that it's Superman. If anybody were at the horizontal, they would have had to tilt their head by 45 degrees such that the laser from their eye, the imaginary laser from their eye, would point to the top of this building. So this new word is really useful. It's a short form for a long story. And a lot of the questions that we will play with all happen to be stories that we will break down into diagrams like this and find the right triangles. Now this is a new word, the line of sight. This is another new word, the angle of elevation. We have one more new word. It's called the angle of depression. Now you may be able to guess what that word should mean because you can see what angle of elevation means. Think about it. Let's play with a scenario to understand what angle of depression is. Now in the second scenario, let's say Superman is on the top of the building. He has finished saving and now he's relaxing. And then there is a citizen walking their dog and they're about to collide with a bicycle. Now Superman wants to save them, but the only thing you know this time is that the angle of depression that they have, the angle of depression of them, the citizen, from Superman's point of view is 60 degrees. That's all you know. But you know what angle of elevation is. So can you guess what this must mean? What does it mean to say the angle of depression of them is 60 degrees as seen from here? Think about that. Now, let's visualize this. Let's again imagine Superman's just relaxing, so he has no idea. So his line of sight is just along the horizontal. He's just looking into the sky. And what happens is that now that he has to look at them, he has to turn his head down. So he's going to turn, and then point towards them. He's obviously not pointing the actual laser. He's pointing towards them. And how much did he have to turn his head? That's what we call the angle of depression. So this distance, this angle that he had to turn his head is what we call the angle of depression. This angle is given to be 60 degrees over here, and that's the angle of depression. That's the other new word that you may want to know, the angle of depression. That's just a short form for saying from the horizontal, you will have to turn your head 60 degrees downwards to see whichever point that you're talking about. So if this point has an angle of depression of 60, it means you have to turn your head 60 degrees from this point to see this. So it's a very short way of representing. So the word depression tries to talk about turning or tilting down, and the word elevation, the angle of elevation, talks about having to tilt your head up. And both of these are always measured from the horizontal. And now, how do you find how far you have to fly? You have an angle, you don't have anything else. So can you find how far you have to fly with just this angle? Even if you're Superman, you actually can't. So what Superman does is, or you do if you're still thinking of yourself as Superman, is that you quickly Google the height of the building. It's a famous building, and you find that luckily the height of the building is 100 meters. So we're actually choosing convenient numbers so that we're not distracted by the numbers when we're trying to learn some new concepts. So you have 100 meters over here, and you have 60 degrees over here. What can you do? You will notice that this is horizontal, the ground is horizontal, this has 90 degrees, we'll come to that. This ground is horizontal, which means this is a transversal that cuts both these parallel lines, which means that this angle and this angle have to be equal. This angle here have to be equal, 60 degrees. Now why is that interesting? That's interesting because now you have a right angle triangle. You have 60 degrees over here, you know the opposite side of this triangle, and you want the hypotenuse. what connects the opposite and the hypotenuse? Sine, right? So if you know sine 60, you're done. The way I try to remember sine 60 is that I remember what I call the 60-degree triangle. What I mean by that is the triangle which has 190, this angle to be 60, and then if this is 1, I always take my base to be 1, then the only thing I remember is that the hypotenuse will be twice the base for cos. In other words, cos 60 is half. With this, I can find the third side using Pythagoras theorem. 2 square minus 1 square is 3, so this will be root 3. So all the ratios of 60 that I want, and bonus because 30 is like hiding over here, I have all the ratios that I want for 30 degrees as well. So with just these two triangles, I can remember all of the ratios that I want, sine, cos and tan of 30, 45 and 60, and this is what I use. And now we can find what this length is, and I'm just going to call it something. I'm going to call it d. So 100 by d will be equal to sine of 60, which is root 3 by 2. So let's write that. So 100 by d. Now you can find, with all this, you can find d, and you know that you can find it for any triangle that has 60 in it. And what is d going to be? From this you can just cross multiply. So d goes over here, it's 200 by root 3. d equals 200 by root 3. Now I'm just going to leave it at that. You can always find the answer to this. So the key takeaway of this video is that all of the questions that we will see will have 3 new words that we will use. One of them is line of sight. Line of sight, which is just the laser that shoots from your eyes pointing in the direction that you're seeing. So if you're not tilting your head up or down, your line of sight is exactly along the horizontal. And then as you tilt your head down, your line of sight is now pointing towards them. And then the amount you had to turn from the horizontal to look at a point with your laser is what we call the angle. And depending on whether that angle is below the horizontal or above, we have 2 names. If it's above, we call it angle of elevation. Let's hope I have space here, angle of elevation. And if it's below, like over here, we call it the angle of depression. These are the only new words that you need to know. And that's it. Once you have these words, and once you remember these 2 triangles, because a lot of us think I have to remember a lot of formulae maybe because there are many questions. Not really. The only 2 triangles you need to remember are these. And if you remember these, you have the basic ratios, sine, cos and tan of 30, 45 and 60. So these are the prerequisites, I like to call them, the things you need to know to be able to solve problems. And all of the questions boil down to taking a story that's given to you and drawing a diagram and asking, where are the right triangles here?